Good afternoon and good morning, everyone. Welcome to today's Exploring by the Seat of Your Pants Hangout. My name is Joe Grabowski, and I will be your host for today. I'm really excited to be hosting today's event. Today, we are joined by Josh King. Josh is a research scientist at Environment and Climate Change Canada, who studies changes in snow in the Canadian Arctic and around the world. So using planes, satellites, and even Twitter, he's developing new methods to measure how much water is stored in snow and better understand its importance. He recently returned from a field expedition in the Northwest Territories using satellite mission concept for snow testing. And he's also probably one of the few people you'll ever meet who loves shoveling his driveway in the winter. So Josh, it's so great to have you joining us. We've got a great group of classrooms from across Canada, and we're really excited to learn a little bit more about you, some of your expeditions, and of course, why snow is just so darn important.
Great, thanks, Joe. Hi, everybody. My name is Josh, and I'm really glad I could join you today for this hangout. I appreciate you inviting me into your classrooms. So welcome to my office here at Environment and Climate Change Canada. If you look around my office, it's kind of boring. So what I'm going to do is share my screen so we can look at some pictures of the Arctic and talk about some of the research we do here. Everything good there, Joe?
We got it, nice and full screen.
Great. All right. So I'm really excited to talk to you all about snow today because we're celebrating Arctic Science Month here at Environment and Climate Change Canada. The Arctic is a really important place to me, and I hope we can learn something together. So as I'm talking today and we're looking at these pictures, I want you to think up some of your best questions about snow or the Arctic, or you can even tell me something interesting that you know about the Arctic. Like Joe said, my name's Josh, and I'm an Arctic scientist. That's a picture of me there on the left. So when people ask me what I study, I like to tell them about something called the cryosphere. Now, this might sound like a bit of a new word, so let's break it down so we can understand what it means. The first part of the word is cryo, and when you hear cryo, I want you to think cold, like really cold. And the second part of that word that you might already know, sphere, think of something round, like a ball. That's a sphere. But in this case, we're talking about something like a globe, or more specifically, the places you could go on a globe. So when we combine the two words, you can find out what I study, cold places around the world. And because these places are cold for almost all of the year, below 0 Celsius or 32 Fahrenheit if you're from the United States, we can find snow and ice for up to 9 months of the year in these places. So what do I study in these cold places? Well, snow and ice. Here's a map of Canada that shows some of the places that our group works. Today, I'm going to be speaking to you from Toronto, Canada. So that's in the bottom portion of Canada here. And I'm talking to you from my office, but most of the work that I do is in the Canadian Arctic, in a lot of places with interesting names like Alert, Eureka, and Inuvik. The thing that's common in most of these places is that it's really cold in the winter. So the map that we're looking at here actually shows what the usual temperatures are in these places. And whenever the colors are getting darker blue, that means it's even colder. So a lot of the places that I work are usually -20 in the winter. So even right now, they're that temperature. And I think that's really cold. But what you might be wondering is, well, what do these places look like in winter? So in this picture, I'm standing out on the ice making some measurements with my colleagues in the Arctic in a place called Eureka, Nunavut. And if I were to stand there and look around right now, just about everywhere around me I could see would be snow and ice on the ground. And that's because in the Arctic, up to 80% of the annual precipitation comes in the form of snow. While I was standing out there, the air was really cold. I think it was about -25 that day, and the wind was really strong. And you can tell that because you can see the snow blowing along the surface. This can make it really hard to keep yourself warm while you're working. But the winter weather in the Arctic isn't always really bad. If we head even further north, here's a picture of me with one of my colleagues working pretty close to the North Pole, actually, on sea ice. And we can see here the weather is nice, it's sunny, and it's calm. I wouldn't want to wear a t-shirt, but with the right clothing, you can really enjoy being out in a place like this. I think it's about -20 at this time, but I remember having a really good sampling that day. Right now, a lot of the Arctic's dark because of the way that the sun orbits the Earth. So we're in a period of what's called polar darkness. But even though the days are getting shorter in the Arctic, we still need to get a lot of work done. So in order to do that, we use flashlights to help us see. The picture here shows me working on some snow, some tools, and you'll see I have a big flashlight attached to my head so that I can see what I'm doing. So what you can see is that work in the Arctic, we're actually exposed to a lot of different conditions. It can be windy, can cold, but it can also be really nice out and fun to work in. Now, scientists like me have been studying snow using satellites in space for over 70 years now. This is important because snow covers about 40% of the Earth at any given time. So even though you and I might not see snow when we look out our window right now, or depending on where you are in Canada, you probably do see snow, there's still plenty around us in all sorts of different places. So the animation here, you can see that we find snow in a lot of different places in North America, going all the way from the Arctic down to the southern United States. But it also changes a lot throughout the year. So when we don't have too much of the white part, that's during the summer when the snow is only found in the Arctic. And then during the winter, like we experience, we get snow. So looking at snow over really long periods, we've noticed two things. The first is that in the spring, our snow is starting to melt earlier. And in general, we're starting to see a lot less of the Earth is covered in snow during winter. Now, scientists like me who are studying this agree that this is not a good thing. And we think that humans are causing this as part of climate change. So let's talk a bit about why snow is important and why we would care if it's changing. So have you ever looked out the window at snow and thought, well, why is it so sunny, or why is the snow so bright and white? Well, that's because snow is really good at reflecting the sun's energy. So you could think of the sun as almost sunscreen for the Earth, where when it's around, it reflects lots of that sun's energy back into space. So you can see here, I've got a little diagram with an emoji sun. The reason that it's really bright there is because it's reflecting all the sun's energy. But when the snow is gone, or it's not there to begin with, the Earth takes on a darker color. It absorbs more of that energy. It can actually produce heat from that interaction. So if you've ever been outside on a hot sunny day and you've touched the road, you might have experienced this, where asphalt or the road covering absorbs a lot of the sun's energy and it gets hot to the touch. Thinking of snow as sunscreen, the air can get warmer. So unfortunately, when this happens, if we melt more snow, this will cause the air temperatures to rise. But if the air temperatures rise, it'll also melt more snow, making this problem even worse. So you can start to understand why it's important for us to study snow. It's a big part of the Earth, and it helps us to keep it cool. Knowing that snow is really important for our climate and temperatures, we also know that it's really important for animals in the Arctic. So the photo that we took on the top part here, that's my buddy, Mr. Polar Bear, who likes to build their home in the snow and hibernate in winter. If snow is changing, then we might affect that polar bear's home. Muskox, like in the bottom here, they also live in the Arctic and need snow cover. They need it to protect their food in the winter. So when there's very little food around, they can dig down underneath the snow, and the snow's protected that food for them, and they can still get at it. So any big changes we have in the snow cover can make it really difficult for these animals to survive. We as humans also rely on snow. One of the main things that we rely on it for is drinking water. So even though you might not see snow, some of it might still be some of your drinking water. Let's think of a really hot place, say California. Now, that kind of place doesn't normally get snow everywhere, but it does up in the mountains. And in order for them to get enough drinking water for everybody, they have to take some of that water from the mountain snow and use it as drinking water. But if we have less and less snow available in those mountains, it's going to be harder and harder for people in those areas to find clean drinking water. Now, humans have also been using snow to get around for a long time. So the picture down here shows some people on snowmobiles, and we can use it to get around where there's no roads, or sometimes we can even use snow to make roads. You might have heard of ice roads before that we use to drive over lakes. I mentioned earlier that scientists use satellites to measure snow and ice. Well, just a few months ago, NASA actually launched a new satellite. the one that we're looking at here. It's called ICESat-2. And that satellite can be used to measure, for example, how much snow has freshly fallen on a glacier, or how much of a glacier has melted. And it uses lasers to do that. So measuring the distance from that satellite to the surface, if we look at the same point a bunch of times, we can figure how much more snow is accumulated, so more snow building up, or melting away, where the distance would get further away. Now, orbiting around the Earth, a lot of times, like in the movie on the bottom, we're able to collect a lot of information around the whole world about snow and ice without actually having to touch it. So we hope this satellite will continue to work for many years so that we can use the data to collect lots of information about snow and ice and improve our science. Now, a big satellite mission costs a lot of money to put into space. So before we even start to launch that satellite, we need to start to do some work. We call that work field work. And it helps us to understand what we would need to do to design a mission like that. So we go to the Arctic and we do tests. Now, a big part of my job is designing experiments where we collect information about the snow to help us understand what would we do if we were to build a satellite. We measure things like how deep the snow is or how much water is stored in the snow. So the two pictures here show us digging down into the snow to take samples. This helps us to better understand the structure of the snow and helps us to better understand how climate change might be influencing it. On the bottom, you see an animation. Now this looks like we're moving really fast, but I've sped up the time to show you all the hard work that goes into collecting information outside. We're always moving, but that's probably a good thing because it helps to keep us warm when it's really cold. Now sometimes in winter, snow can look all the same. But as scientists, we use a lot of different tools to help us look at snow. So in this picture, you see me out on the snow, and I'm using something. That tool in my hands here is called a microscope. So this tool allows us to magnify the snow and look at a lot of detail that we normally wouldn't be able to see with our eyes. So this picture up here, that shows what snow looks like after it's been on the ground for a long time. Now, when you think of a snowflake, it doesn't usually look like that. But after snow sits on the ground for a long time, it changes. Now, if we look at lots of different parts of the snow, we can start to read it like a book and start to understand how things like temperature and wind has affected it. Now, I'm not sure how many times I've mentioned that it's cold outside in the Arctic, but it really is. And being really cold, you can see in these pictures, we have a bunch of people who've been working outside really hard all day, and they have ice all over their face. Now what that is because it's so cold, when we sweat, that sweat freezes to our faces. Now the ice doesn't hurt us when it does that, but it sure makes us look funny. So we have to make sure that we're dressed really well and prepared for all the cold environments that we're going to work in. To do that, we wear some things that are pretty similar to what you might wear in the winter. Things like goggles and hats and face masks. They help us keep us safe from the cold. We also have to wear a lot of thick, warm jackets, gloves, big boots, and snow pants. And of course, because we're working so far away from cities or hospitals, we have to carry equipment with us in case we have to stay out on the ice, like tents and other types of survival equipment. We even carry food with us in case we have to stay overnight. Now, when we're up in the Arctic, like I said, we're pretty far away from cities and houses. So where do we stay when we're there? Well, we have to bring our own houses with us. In this picture here, you see my house. So I just returned from an expedition that we did in a place called Trail Valley Creek. This is up in Canada's Arctic in the Northwest Territories. And when we're living there, we each live in our own little tent. On different campaigns, the tents change. Some of the tents have ovens in them to keep us warm, but these ones don't. So I have to sleep in a big, thick sleeping bag to keep myself warm. When I wake up in the morning, it can sometimes be -20 inside of that tent. So I have to make sure that my sleeping bag is really good to keep me warm. With snow all around, the best way for us to travel really long distances is usually with a snow machine, or sometimes we call them skidoos. So the picture here shows 3 of the skidoos that we use when we're out in the Arctic. And we can ride over the snow really quickly with these to get where we need to. We carry a lot of scientific equipment with us, so we have to attach toboggans to the back of these. You can see the yellow toboggans here attached to the back of each snow machine, and each one is loaded with our equipment. This lets us get around really quickly and bring things where we need them. When things are really far away, like when we head towards the North Pole, we sometimes have to use planes to get around. So the plane in this picture is a special one that has skis attached to it so that we can land on the ice. With the help of our pilots, we're able to go places that are usually impossible to get to, like the North Pole. In the video here, you can watch from our pilot's view as we land on the snow where there's no runway at all. We have some really talented pilots who keep us safe, and this allows us to get to places that we need to sample in the high Arctic. Now, working in the Arctic, I mentioned that a lot of these places are really important habitats for animals. So we work in a lot of places that animals call home. Because of that, we sometimes get visitors while we're working. In this photo, in Churchill, Manitoba, we had a polar bear decide to come and see us while we were working. Now, we had to be really careful here and make sure that we got inside safely, but one of my friends was able to take a picture from pretty far away as that polar bear peeked around the window. Humans can be pretty interesting to animals in these areas because they don't usually see them. And like I said, we have to be careful to respect that life in these areas because it's truly their home and we're just visitors. So here's a picture of some wolves that came to visit us while we were working on ice near Eureka, Nunavut. The big wolf in the big picture came and gave us a big howl before it started to wander away with the rest of the pack. And we really enjoy seeing these animals, but we're careful to be safe around them and try really hard not to interfere in their lives. So I hope you enjoyed our little tour of the Arctic and learned something about snow. I really enjoyed getting to talk to you today, and I hope you've got some great questions for me because I'm excited to answer them for you.
All right, Josh, thank you so much for sharing some of your work with us, what it's like working in the Arctic. That was awesome. You almost have me excited about all the shoveling I'll have to do this winter. So thank you so much for sharing that with us.
Oh, my pleasure.
All right. Well, like I mentioned before, we have a great group of classrooms joining us. We have some tuning in on YouTube as well. So any classrooms who are joining us via YouTube, use the YouTube chat sidebar on the right. Let us know where you're watching from. And of course, send us in a question or two. But for now, let's start meeting some of our live classrooms. So let's start off. Let's go to Alberta this time. We're going to go to Mrs. Katzo's class. There's some grade 5 students joining us.
I'd like to ask a question.
How's it going, grade 5s?
Good.
Good.
Okay. Yeah. Do you want to ask a question? Nice and loud so they can hear you.
Why did you choose to be a research scientist?
When I was really young, I used to love playing in the snow. And I was able to turn what I loved doing as a kid into a job. So when I was at home and I was really young, I used to dig in the snow and build snow forts. But when I was doing that, I was starting to notice that there was a lot of different types of snow. And when I would look out, everything looked the same. But when I would dig into the snow and build my snow fort, everything was different. And that got me thinking, why is that? And somehow I was able to go to school. I was able to read a lot of books. And I found a way to take something that I really enjoyed as a kid and make it my job.
All right, awesome. It pays to be curious and to follow your passions. Let's see. Let's visit Mrs. Whalen's class is joining us from Renfrew, Ontario, grade 5 students. I see the camera's working now. Mrs. Whalen, I'll just need you to help me out. Your camera or your microphone is just off of my screen. Do you mind unmuting for me? And then we'll get your question. So it's at the front. It looks like a microphone. If you click it, it should turn from red to white.
There. How's that?
We got you. How's it going, grade 5s?
So Lacey has a question. Go ahead, Lacey.
How do you get your food?
Did you ask me how we get our food?
Yeah.
So we usually have to bring our food with us. The reason is there's not much available where we are. We don't want to interact with the animals too much, and there's not too much to eat from trees or anything. So we have to bring a lot of our food with us. That means packing food into bags and carrying it. So in order to do that, we have to be careful about what we bring. We can't go to the grocery store and just take a lot of really big boxes of cereal or anything. We have to make sure it fits into a pack sack or it fits into something that we can put in a sled. But we still eat pretty normal food. For example, in the morning, we'll have oatmeal for breakfast. And then for dinner, maybe we'll have pasta with some sauce. But the one difference is when we go to eat lunch, we usually have to do it when we're outside. So we don't have a big lunch usually. We just take some trail mix or some crackers or a granola bar and just eat really quickly. I like to take a thermos with me too, so that I can have some soup at lunch maybe, or something nice and hot to drink to help me warm up. Makes me feel a lot better when it's really cold out.
Josh, when you're in the colder environment, do you have to eat more calories?
You're definitely a lot more hungry when it's cold out. Even if you're not moving outside, you're burning a lot more calories than you are when it's nice and warm at home. So when we're out, sometimes we have to eat a chocolate bar or something like that just to keep ourselves going with a lot of energy.
All right, let's take a little visit to another classroom. Let's go to Mrs. Gill's class, some grade 5-6 students joining us in Cambridge, Ontario. Let me turn their microphone on. How are we doing, Cambridge?
We are great. Okay, Jack, just come on up to us.
Okay. So Josh, what do you hope to achieve with your study, and why is it important?
Great question. The one thing that I'm really hoping to achieve is to create some sort of representation of how much water is stored in the snow around the world. So right now we're good at doing it at very small places. So like I was showing you, we can go to the field and we can measure it at just one site, but we're not very good at representing it across the whole world. We know that climate change is really affecting the amount of water that's stored in the snowpack, but we're still looking for that perfect method to measure it. So in my career, what I would really like to do is to take the science that I'm doing in the field and build a satellite mission from it so that we can measure it around the whole world and benefit everybody. I think that that's something that we can do in our time within my life, and we're actually working on it right now. We have a joint project with the Canadian Space Agency where they're trying to help develop a satellite, and we're trying to look at the science to do it. I think it's really important that we continue to work towards these really big projects because we can help humanity as a whole if we do it.
All right, great question. Let's go now to Mrs. Garvey's class. There's another grade 6 class joining us from St. Anne's in Ontario. Let me turn on their microphone. How are we doing, grade 6s?
Yeah.
What animal most
In the environments that I work, I think it's hard to say which exact animal is most impacted, but that's still a great question because I think it's important that we look at all animals. If one single animal is impacted by it, it might affect a lot of other animals. So for example, if a caribou is affected by the amount of snow that's available and it can't eat, perhaps there's another predator that depends on the caribou being there. So even if snow is not directly affecting one specific animal, it might still be affecting them because there's another animal that they depend on, or a type of plant that's affected by it that they eat. All these systems are interconnected. So when we're able to look at something and figure out how snow is impacting one species, we might be able to better understand how a lot of different species are impacted by it as well.
All right, we're going to head to Prince George, British Columbia this time. Mrs. Caesar's grade 6s are joining us. Let me turn their microphone on. How are we doing, Prince George? Oh, let's try that again. How are we doing, Prince George?
Good.
That's better.
So why is snow icy after it melts and refreezes?
That's a great question. So the texture of snow, I'm sure you've noticed, changes a lot when it refreezes. So when snow falls from the sky and it lands and creates a snowpack, so that's snow building up, it's pretty lofty. So if you were to stick your hand into it, it's a mixture of snow, which is frozen water, but also air. Then as the snow melts, it's actually turning into something that's closer to water. So it's a mixture of snow and water. And then when it refreezes, there's less and less air. So the more and more ice that's available, the slipperier it's going to get. So if you have snow that's nice and lofty and crunchy, you can walk through it, no problem. But as it melts and turns into ice, then it becomes really slippery. So in the Canadian spring, this could be a pretty big problem. Or even on roadways where we have things like black ice because the snow is melted onto the road surface.
All right, let's visit Mrs. Durnan's class. They are in London, Ontario, another grade 6 classroom. Let's turn their microphone on. How are we doing, grade 6s?
Ready?
Okay.
Nope. Okay, first question, go.
What do you think is having the biggest negative impact on climate change today?
The biggest impact on negative impact? There's a lot of different things that are impacting climate change these days, but I'm sure you've read about greenhouse gases, and greenhouse gases are a big problem. I think as countries and as citizens, we all need to look at what we're doing each day and better understand how that's contributing to things like greenhouse gases. Even as an individual, you can make some changes in your life that can help to improve things. So even though when we think about greenhouse gases as being a big problem that, say, a factory is creating, if we all work together and make little changes, perhaps that can, what we would say, mitigate or make smaller that impact as a human species.
All right, and our final live classroom is joining us from Toronto, Ontario. We've got some grade 9s with Mrs. Almeida. Let me turn their microphone on. How are we doing, grade 9s? There they are. All right, who's got a question?
Okay, so I have a question. So what are the benefits and pros of the job, and can you elaborate on how that relates to your personal interests, such as the pay and the work environment?
Sure. I think the positives for me are that I get to work on a problem that I find extremely interesting. When I come into my job each day, I'm engaged. I find things that I would like to pursue as a research question that are of benefit to Canadians as well. So I'm not necessarily coming into a job each day where I'm told you have to do these tasks. I'm identifying problems, I'm working on problems, I'm collaborating with other people who are also interested in these problems, and I find that really engaging. I'm sorry, could you repeat the second part of the question? I forgot it.
How that relates to your personal interests.
Sorry?
I said that, can you elaborate on those interests and how that relates to what you personally want from this job?
Okay. So my background was in looking at interactions between radar and snow. So I studied for a long time looking at physics and looking at geography and how we could better use that to understand climate change. My personal interests growing up had a lot to do with snow. I was a ski patroller growing up, so I worked at a ski hill. I had a strong understanding of snow. I was able to translate that into some research interests that I pursued in university. I think that looking back, I as a kid, I didn't realize this, and it's important to understand that when you have curiosities, that you should investigate them. There's meaningful things to be done when you're young, even when you don't think they might be meaningful, and that can lead into real interesting job opportunities. Growing up, I liked snow and I liked programming, and this is where it led me. It was a strong base in understanding how to use physics, computer programming, and snow to get a job that I'm really engaged with every day.
All right. Let's start visiting our classrooms again. So Mrs. Katzo and Alberta, we're going to turn your microphone back on. Oops.
There you go. Okay.
What data did you get from Twitter, and how does it help you?
Yeah, so this is something I didn't actually get to talk about, so thanks for bringing it up. I started 2 projects a couple of years ago. I started one called Snow Tweets. The idea with Snow Tweets was to ask people to take their cell phones, go outside, put a ruler in the snowpack, so you measure how deep it is, and go on your phone and tweet at snow tweets and then the snow depth and then a location. So say your postal code or coordinates from a GPS or just your street address. We were continuously scanning Twitter for people doing that, taking that information and using it in our models. That was a really interesting project. There's actually a couple new ones. I think Joe's going to post some links to them later where you can contribute to those. So you can go out in your backyard, you can go out when you're hiking, anything like that, collect snow information and contribute it over Twitter. Another way that we're using Twitter to better understand snow is we're looking for people just talking about snow on Twitter. So if you go on your phone and you say, hey, it's snowing in my backyard, to you that might not seem like data, but to me it is. So a lot of people's cell phones will give a GPS coordinate of where they are. So we can take people mentioning snow and use it to check where our weather model's correct, where our estimates of snow depth correct. We're starting to do that. It's a really complicated process, but we're trying to better understand how we can use things like machine learning or artificial intelligence to extract information like that from Twitter. I really like using Twitter not only for collecting data, but I find it's a great way to communicate. So if anybody wants to follow me on Twitter, you can actually take a look in real time a lot of the time. When I'm in the field, I'll be able to post information. So although we can take data from Twitter, I also find it's a really good way to engage people. So I can talk about my science. You can ask me questions. It's a way for people to access other people where they normally won't be able to. So great for data, great for talking about science.
All right. And as Josh did mention in the YouTube chat sidebar, I did post links to two of those projects, the snow tweets and the community snow observations. You can check those out with your classrooms. And then Josh, you're at Geomatics on Twitter. So classrooms, please do take some pictures of today's event and make sure you tag Josh so you can check those out afterwards. So we'd love to see the pictures of the classrooms in action. Let's jump to, let's go to Mrs. Gill's class this time. Your microphone is on.
Okay. How has global warming impacted life in the Arctic?
Global warming is having a lot of different effects in the Arctic. Some of them we're seeing even today when we go up. So with my expertise, we're seeing the amount of snow is changing. So as temperatures are getting warmer in the Arctic, we're seeing less and less snow in the spring, and we're also seeing it melt earlier. Now, directly, we see this as snow being the issue, but that snow is really important to things like shrubs. So with less snow, the shrubs are actually growing more and more in the north. So we're seeing what's called greening of the north, where different vegetation that usually isn't found in the Arctic is starting to grow farther up north. We're also seeing things happen like animals who depend on those environments, like say caribou, maybe if there's more rain on snow events. So if the temperatures are warmer during the winter, you might have rain instead of snow happen. If that rain falls onto the snow and freezes, it might make it hard for an animal like a caribou to break through that snow to get food at the bottom. If they can't get food, then it's really hard for them to survive. So whenever we identify one issue of climate change affecting the Arctic and we see it happening, I think it's important that we realize that these things affect a lot of different things. So it's never ever we look at snow and we see snow as being affected by climate change and it's not affecting anything else. It'll affect it'll affect people, it'll affect animals, it'll affect the ecosystem. There's always some follow-on influence there. And it's really hard for us to all understand it at one time. So what we do is we often collaborate. That means that we work with different people. So my expertise might be in snow, but I have colleagues who are experts with wildlife. I have colleagues who are experts with oceans. We try to work together because it's too much work and it's too hard for one person to understand everything. So if we work together, we can get to an answer much quicker.
All right, Mrs. Whalen, if you don't mind turning your microphone on, we'll steal another question.
Hi there, sorry.
Hello.
That's okay. We got you now.
She's taking pictures.
Go ahead, Kira.
How big are the usual polar bears and are they dangerous?
I actually don't have a good answer for you on that. My expertise isn't with polar bears, but I can tell you that they're much bigger than me. I think I've heard people say in the numbers of 700 pounds or bigger, but I'm just saying that because I've heard someone tell me. The polar bears aren't something that we want to approach. They're wild animals, and we have to respect that we're in their home when we go to these places. So when we do see polar bears, the first thing we do is try to leave. That's important because we don't want to interfere with what they're doing, and they are very big. They could hurt us, but we make enough different safety procedures that we always make sure that there's someone watching. So if I'm doing work, I have someone beside me who's watching for danger. And if they see any sort of danger, like a polar bear, they just tap me on the shoulder and we leave. The polar bears aren't quick enough to catch us on our snow machines, but we have to be very proactive and make sure that we're making our environment safe. That's really important.
All right, great question. Let's turn on Mrs. Garvey's microphone.
Yes.
What's the longest time you've been working in the Arctic, and has anything crazy ever happened?
The longest time I've ever spent consecutively working in the Arctic was 2 months straight. I always try to come home and see my family. It's really important to me because sometimes when we're up in the Arctic, we don't have internet. We're out in the middle of nowhere. So staying for a really long time in these remote camps is kind of hard for me because I want to come home and see my son. I want to come home and see my wife. So I try not to stay super long, but 2 months was about the longest. Lots of interesting things happen in the Arctic. Equipment breaks all the time. So you'll often find yourself out in the middle of nowhere with a broken snow machine or a skidoo. And what do? You very quickly learn how to repair engines, or you very quickly learn how to become an electrician. I think one of the really key things in the Arctic is that a lot of these crazy stories end with us becoming partial experts in areas that we didn't think we would be. So we might become a repair person for a tent, or we might be able to make a makeshift shelter. Although we do have some interesting stories, I think all those stories always end in good conclusions. And one of the reasons is that we prepare a lot. We have safety plans, we have people who are watching out for us, and we're all really well trained in what we do. So as part of your job, if you're asked to go and do something that's dangerous or asked to go and do something in a remote area, you have to make sure that you have the skills and the understanding to get that job done, that you come home safe to see your family too.
All right, back to British Columbia with Mrs. Caesar's class. Your microphone is on.
Hello. My question is, does snow make you more dehydrated than you were before?
No, we actually do drink snow when we're in the field. So one of the things that is really hard to bring with us is water. So what we'll do is we'll take a big pot and put it on a stove and put water in it. We'll put snow in it, and we'll boil that to get rid of any bad things in it, and then we'll drink that. I think what you might be thinking about is seawater. So when water has a lot of salt in it, you don't want to drink it. So if you were out on the ocean and your only source of water was the ocean, you probably wouldn't want to drink that. But if you're able to take snow and you're able to heat it up and boil it, you can drink it as a source of water, absolutely.
All right, I just took a little peek over Twitter. I see some classrooms have already been posting some pictures from the Hangout, so that's awesome. Keep them coming. And just a quick reminder as well to tag ECCC SciTech. So that's the Environment Canada and Climate Change as well. So make sure that you tag both of those. And we're going to jump to Mrs. Durnan's class. I'll turn your microphone on.
There you go.
What can we do as students to help slow down the melting snow?
I think you can make a lot of small changes in your life. Maybe you have, say, a public transportation system in your town. You can take the bus, or maybe you like to bike. You can ride your bike to school. There's lots of small changes that you can make in your life to improve our environment. I try and take the subway to work and the bus to work as much as I can to make those small changes myself. but I also know that those are hard changes to make. So you really have to work towards these things in your life. But when we do these small changes as a group, they add up to big things.
Yeah, I think too many times we worry about one small act not having a big enough impact, but it's other people seeing you and being that leader who starts, who kind of gets that movement going, gets other people following in their footsteps, and then that can really get things going. So one act can turn into a lot. Back to Toronto, Ontario with our grade 9s. Your microphone, oh, you've got it on for me already. Go ahead.
Yes, hi. Sorry, our class is actually over. Can we just ask really, really quickly, and we have to go. I'm sorry.
That's okay.
Thank you.
Oh, ask quick. Okay, so what advice would you have for high school students interested in this field of study?
Sorry, I didn't catch the last part. You're interested in what? Sorry?
What advice would you have for high school students interested in this field of study?
Oh, yeah, get involved. If you're interested in this kind of research, get involved. There are different things that you can do. We talked a little bit about those Twitter projects. A lot of local conservation authorities run snow courses. So what a snow course is are snow measurements that are made, say, monthly or weekly to better understand how much water is available in snow to, say, a river. You can contact people like your local conservation authority and see if you can volunteer to be part of those projects. Perhaps they can give you some training on how to collect snow information, so depth or water equivalency. And then you can start to build an understanding of how snow measurements are made and how they can be contributed to other studies. As for other opportunities, I think things like cooperative education are always good to get involved. But I think just starting conversations with people, if there's a researcher that you're interested in, see if they have a Twitter handle and send them a message. Ask them questions. Sometimes scientific literature can be intimidating, but often if you talk to these people, they're really happy to explain it to you and help you to get involved.
All right, I think that's some great advice. We live in such a connected society right now. You can find so many different scientists and explorers on Twitter. You can reach out to them and ask questions. And you know what? They all started off just like you. They met someone, they saw a documentary, read something, and it kind of kickstarted something for them. So they're generally really happy to answer your questions and help out. So I think that we visited every classroom twice. If I've missed a classroom, give me a huge wave if we haven't visited you a second time. But I'm pretty sure that we've hit every classroom twice. Excellent. All right. Well, Josh, first of all, huge thank you to our classrooms who joined us from all different places around Canada. As always, your questions were great. It's so great to see so many excited students hanging out with us. And Josh, thank you so much for sharing your work with us. And thank you for doing your part to monitor our planet and look for solutions.
Thanks for having me. This was really fun. If anybody wants to ask more questions, feel free to send them to me on Twitter. I'm always happy to answer.
All right, excellent. So just one more quick reminder, I did post a couple links to some of those citizen science projects on the YouTube chat sidebar, but if any teachers would like them directly, just send me an email after the Hangout. And the last thing we'll do before we sign out for today is turn on all the microphones, let the classrooms get a little bit loud, say goodbye and thank you, and we'll sign off for today. So here we go, microphones are coming on. Good job, boys and girls. Once again, thanks for hanging out with us today. Enjoy the rest of your day. Thank you so much. Look forward to following along on future expeditions. Thanks, everyone.
See you later.